You have something working for you all the time to keep you alive, and you don't even need to think about it. Your heart beats 80 times a minute, 115,000 times a day, 42 million times a year, and over 3 billion times in your life. How amazing is that?
Oh, yeah.
So blood flow through the heart is an important and an amazing concept to learn about. And as you guys know, I started taking physiology and anatomy last semester, and I started learning about the complexities of the human body and what it takes for it to function properly. And I began to be really fascinated about the cardiovascular system and what it takes to keep our heart beating strong throughout our entire lives. So even if you're not going into the medical field, it's still a really enlightening thing to learn about how your heart keeps you alive throughout your entire life. I'm going to be talking about the anatomy of the heart, and then I'm going to talk about the cardiovascular system and how blood flows to and from your heart. And then I'm going to talk about blood flow specifically within the major chambers of your heart. So to understand blood flow through the heart, we have to understand the anatomy of the heart and how it's structured. So you can look at sheet A that I sent to you to get an idea of what the heart looks like. So we have 2 upper chambers called atria, 2 lower chambers called ventricles. And then the heart is divided into a left and right section by a septum. And then we have one-way valves that keeps blood flowing in one direction and prevents backflow. And the valves closing is what creates our heart sound that we know. If you've ever heard your heart in a stethoscope, that's what you're hearing. Sandra Goldsworthy mentions in her ebook titled A Compact Clinical Guide to Arrhythmia and 12-lead EKG, how a cardiac cycle refers to the repetitive pumping of the heart that includes all of its parts working synchronistically to get blood flow through the heart and the entire body. So what she's mentioning really stresses the importance of how the anatomy of the heart works to help its function of pumping blood through our heart and our body. So now that we know some of the anatomy of the heart, let's talk about the cardiovascular system and how blood is pumped to and from our heart. So I want to talk about the key differences between arteries and veins. So if you could look at sheet B, I'll be talking about that sheet. The main difference between arteries and veins is that arteries are pumping blood away from the heart and veins are pumping blood towards the heart. So arteries are much thicker than veins because they're under higher pressure because they need to pump blood away from the heart that's oxygenated to the entire body. The largest artery in the body is called the aorta, and it pumps blood to almost your entire body. And our arteries branch off many times and form complicated networks in order to deliver oxygenated blood to every cell within your body. Armando Vasudagan is a practicing physician in Sydney, Australia, and he makes a lot of medical educational videos, and he talks about the pathology of atherosclerosis and how it is a calcification buildup and hardening of the arteries, and how it prevents and restricts blood flow. And what he mentions in this video really helps us to appreciate the healthy anatomy of arteries and veins. And if anything blocks the blood flow, it could lead to medical emergency. And so it's really important to understand how arteries and veins work in order to appreciate how they function and help with pathologies. And now that we know about the cardiovascular system and the anatomy of the heart, we can track how blood goes through the heart. And we're ready to trace a red blood cell within the major chambers of the heart. So first we have deoxygenated blood entering into the right atria, and it goes through the tricuspid valve into the right ventricle, and now it's ready to go to your lungs to get oxygenated. It will go through the pulmonic valve, out the pulmonary artery, because remember, arteries take blood away from the heart and to your lungs. And now it's getting oxygenated and it's ready to come back to the heart through pulmonary veins. Veins bring blood back to your heart and into the left atria, and then to the left through the bicuspid valve to the left ventricle. And this oxygenated blood is ready to go to your body. It leaves through the aortic valve, out the aorta to the body. Now, once blood leaves your body has a way of sensing when you need to increase red blood cell production. So, in a journal by Clemente and Aria Fernandez titled "How Do Red Blood Cells Know When to Die?" they mention how when your blood passes through your kidneys, if low oxygen levels are sensed, erythropoietin, also called EPO, is released into your system, and if low oxygen levels are sensed, the erythropoietin is released, and your bone marrow is triggered to increase red blood cell production. So this could help us appreciate how when blood is pumping through our system, from our heart to our body, how physiological mechanisms kick in order to keep our body at a set range and keep us balanced and healthy. And I hope you appreciate how red blood cell travels through our body and through our heart. And next time you go to the gym and you feel your heart racing, or your heart skips a beat when you look at your fiance or your dogs or your cats, I hope you remember how your heart is always working to keep you alive and how it's keeping you healthy. The cardiovascular system is a really important thing that's keeping you alive throughout your entire life. Does anybody have questions?
Yes, I have a question.
What is your question?
Great job, by the way. So, EPO. So, when it takes from the bone marrow, does that affect your health in any way? Like, is that bad for you when there's not enough oxygen in your blood and then it's taken from the bone marrow? Because I know that when we don't have enough nutrients in our system, sometimes the body will take from the bone marrow and then it will, hurt our bones.
Hurt your bone. I don't know if it hurts your bones. I know from what I understand at my level, I know if you're like anemic and you're producing too many red blood cells, I think you produce too many immature red blood cells, right, Richard? And then, so you're not producing the proper red blood cells you need, but they eventually become mature.
I would suppose that if you were needing to take from your bone marrow on a regular basis, it would be bad, but once in a while, it's not going to hurt you. Just like your body, when it's under stress and you don't have enough calcium, it'll take the calcium out of your bones to calm you down.
Right.
So that's okay once in a blue moon, but probably the similar thing where your body takes from wherever it needs it from to get it regular.
Oh my goodness.
Beautiful.
Yes.
That's very cool. I didn't, from the bone marrow, huh?
Yeah, that's where we produce red blood cells. I think I was freaked out by that at first myself.